Hello, what I have for you today is our review for the second exam for the first 9 weeks. So, this is exam 1.1. It is going to cover matter, density, physical and chemical properties and changes, and also kind of just a little bit of the periodic table. So, in your review, you have several problems here. And these are all density examples. You will have some density questions on the test, and you're going to have to use your calculator in order to calculate density. So remember that the formula for density is mass divided by volume. That will be provided to you also, so it's not something you have to memorize. But density is equal to mass over volume. So mass is going to typically be in grams, or it could also be in kilograms. And then volume could be in centimeters cubed if it's a solid, or it could be in milliliters if it is a liquid. So what you want to do is you want to read the question and figure out what your mass is and what your volume is, and then divide them. So remember, you're always dividing mass divided by volume. Do not switch the numbers, right? Like, let's say you have a pizza and you have 8 people that are going to be splitting the pizza. You divide that one pizza into 8 parts. It's not the same if you divide the people into one pizza, right? That doesn't even make sense. So always do mass divided by volume. So if you look at the example here, your mass is 27 grams and the volume is 10 centimeters cubed. So you do 27 divided by 10, and your answer is 2.7. Now for number 1, which is the only one that I am going to go over, but you do have to do the rest on your own. It says a loaf of bread has a mass of 500 grams and a volume of 2,500 centimeters cubed. What's the density? So you're going to do 500 divided by 2,500, and my answer is 0.2 grams per centimeter cubed. Notice how I got my units from the original numbers, so I just do grams per centimeter cubed. If it's a liquid, then it would be grams per milliliter, or whatever unit they give me. Then I have the properties of metals, nonmetals, and metalloids. So remember, you need to memorize the metalloids. So remember, baby Sally gave Ashley some tea. That's going to help you with the symbols of the metalloids. And then you have to remember that all of the elements to the right of that are nonmetals, and then plus hydrogen, right? And then all of the elements to the left of that, which is the largest group, are going to be metals. And you do need to memorize their properties. But I'm going to tell you right now, like I've said in class, if you just think common sense, this is going to be easy for you, right? Picture a metal in your head and think, okay, well, what does it look like? How does it act? It's going to be a good conductor, right? That's why we use metals to cook and for wires and things. That they are shiny. Usually they're going to be silver or gray, and they are malleable and ductile. That means that I can flatten them into sheets if I hammer it, or I can shape it into wires, like to charge my phone. So those are the properties of metals. And then remember, nonmetals are just the exact opposite. They're bad conductors. They're dull, meaning not shiny, and they are not malleable or ductile. They are brittle, which means that they break into pieces easily. If I hammer it, it's going to crumble. Then I have properties of metalloids. Remember, metalloids are like your friend that can never make a decision. So they have properties of both metals and nonmetals. So they can be shiny or they can be dull, and they're just okay conductors. They're kind of meh, right? They're not good conductors like metals, but they're also not as bad as nonmetals. So, physical changes and chemical changes. Remember, when something undergoes a physical change, it is still the original substance. There's nothing new that has been made. So, examples of physical changes are going to be a phase change, meaning if something turns from a solid to liquid or gas, or vice versa, or anything. Anytime something dissolves, like when I put sugar in my tea, or I make salt water, that is just a physical change. It's still salt and water. We're going to skip number 3 because I don't know what they were talking about there. And then number 4 is talking about a change in shape. Like this example is talking about hammering a piece of copper. So it's still copper, right? Or if I have a piece of paper and I cut it into pieces, it's still paper. So that's a physical change. And then something that's getting crushed or made into smaller pieces, kind of like the paper I just said. This example is a sugar cube. That's also a physical change. Now, a chemical change is when things get exciting because something new is made. The originals no longer exist. They have become something new that wasn't there before. So, examples of that is whenever a gas is formed, there's bubbling and fizzing, or something rusts. In other words, there's a color change, an unexpected color change, or a precipitate is formed, which means that a solid comes from two liquids that are being mixed together. Also, if there is a change in temperature, meaning the release or absorption of heat, something gets hot or cold, that is also evidence of a chemical change. Here are some examples of physical and chemical properties or changes. So just, again, very important, remember that if the original still exists, then that means that it is a physical change. And if there are new substances, that means that a chemical change has occurred, that the original no longer exists. Now on to the periodic table. A family, which is also called a group, is going to be vertical, so up and down, and a period is going to be horizontal. So on the periodic table, we have 18 groups or families, and we have 7 horizontal periods. So an easy way to remember this is like at Memorial, we have 7 periods throughout the day. On the periodic table, we also have 7 periods. For the next few sections, you're just going to practice using your periodic table. You will have a periodic table on the test, but it is going to be colorless. So it's going to be white. It's going to have all of the information, it's going to have the atomic number and the symbol and the name of the element and all of that, but it's not going to be colored. So you need to remember those metalloids. Remember, baby Sally gave Ashley some tea, and you need to remember non-metals to the right, metals to the left, okay? Here you're going to just look for these elements on the periodic table, tell me their symbol, and then you are going to for number 4, you're going to look for the names based on those symbols. On number 5, you're going to tell me what period those elements are in. Remember, it's going to be 1 through 7. And then on number 6, there are 18 groups. So your answers are going to be 1 through 18 here, depending on which element it is talking about. And then here same thing, but you're going to be giving me the names of these elements. Like, for example, to start off with, letter A, hydrogen, right? So you're going to write the name hydrogen. And then here we're going the opposite way. It's giving you the name of the element, and you are going to write the symbol. So for example, letter A is neon, and the symbol is Ne. Okay? If you have any questions, please ask your science teacher. Have a great day and good luck on the test. Bye.